All right, here we go with the following unit, Unit I, which talks about quadratics. In this unit, we're going to be talking about solving quadratics and factoring quadratics. So first, we're going to talk about factoring out using the greatest common factor, and then throughout this unit, we're going to learn different ways to factor. First, I want to start off with some review. Let's distribute the following. Here we have 3 times x plus 2. In order to multiply this out, we have to distribute it to every term. So we have 3 times x gives us 3x, and 3 times positive 2 gives us a positive 6. This next one we're distributing. We have 4a. The exponent here is 1. Remember, if it's not written, the exponent is 1. And we distribute it to every term. So we multiply numbers with numbers, variables with variables. So 4 times 5, we have 20. And a to the 1 times a to the 2, or a squared. We add the exponents, so we have a to the 1 plus 2 gives us a cubed. And then we have 4 times 8 is 32. We have a to the 1 plus 4 is a to the 5th. For the next one, we have 3 times 7 gives us 21. C to the 1 times c to the 4, this c to the 1 plus 4 gives us c to the 5th. D to the 3rd times d to the 1 is d to the 3rd plus 1 is d to the 4th. And then we have 3 times 9 is 27. C to the 1 times, there's no c here, so that just comes along for the ride. And then d to the 3rd times d squared is d to the 3 plus 2 is 5. So again, during this unit, we're going to be talking about factoring and solving. First, I want to define what is factoring. So factoring, it's similar to what we did here, but it's the inverse operation. So what we did here is distributing. Factoring is when you undistribute. So it's the inverse operation to distribution. So when we're multiplying here, we're doing the opposite. We are factoring. We're dividing. So in a more technical term, we are breaking up an expression into two parts that when multiplied together, so when we multiply those two parts together, they equal the original. So again, we're going to be learning a lot of different ways to factor. One of the ways that we're going to learn in this objective is using the greatest common factor. Let's go ahead and define that. So this is the greatest common factor. We shorthand that, we call it the GCF. So that's the abbreviation, GCF. So when factoring out the GCF, looking at this expression here, we have 3 terms. When we're factoring out GCF from here, we're going to end up with 3 terms. And those are going to be inside of parentheses. So first, let's talk about the numbers. When we're factoring out numbers, we want to pull out the GCF. And in other words, this is the highest number that they all have in common. So an example, I'm looking at the numbers here, 15, 25, and 20. What's the highest number that they all have in common? Well, in order to determine that, we can list out the factors of each of those. So what numbers multiply together to get to 15? Well, we have 1 and 15. We have 3 and 5. What numbers multiply together to get to 25? We have 1 and 25, and 5 and 5. What numbers multiply together to get to 20? We have 1 and 20. We have 2 and 10. And we have 4 and 5. So looking at these lists of numbers, what's the largest number, the highest number that all of these lists have in common? You can check. It is 5. So already we can pull out a 5. So that goes on the outside. So let's go ahead and pull it out. What number times 5 gives us 15? That would be 3. For the next one, what number times 5 gives us 25? That would be 5. And then what number times 5 gives us 20? That would be 4. So now we've dealt with the number side of it. Let's talk about the variables. So in the variables, we want to pull out the amount, the smallest amount, all the terms have. So that would be the smallest of each. So what do I mean by that? I'm looking at the variables here. Well, here, let's look at the A's. Here we have 2 A's. We have, it's not written, so there's 1 A. And then here we have 3 A's. Well, between 2 A's, 1 A, and 3 A's, what's the smallest? 1 A. So we can pull out 1 A. And then for the B's, we have 3 B's, 4 B's, and 2 B's. The smallest of those is 2 B's. So we can pull out a B squared. So what happens on the inside? Well, for this first term, we have A squared. We pulled out 1. So A to the 2, we pulled out 1. There's 1 left over. We have B to the third. We pulled out 2. So what's left over? Just 1. For this next one, we have A to the 1. We pulled out 1, so we don't have any left over. So you don't have to write an A term. For the B's, we have 4. We pulled out 2, so we have 2 B's left. And then lastly, we have 3 A's. We pulled out 1, so we have 2 left over. And then here we have 2 B's. We pulled out 2, so we don't have any left over. So this is our final answer. So what we've just done here is we have factored out 5ab squared. What we factored out is the GCF. This is the greatest common factor of each of these terms. If you were to distribute this back in, you can try this on your own. If you were to distribute this back in, you would get the original expression here. So let's try a few examples. Here I want to find the greatest common factor. So we start with numbers. We have 36, 24, and 30. So you want to find out what number goes into each of these. What's the biggest number that goes into each? Well, I know 1 goes into each of them, of course. That goes into any 3 numbers. 2 goes into each of these. They're all even. Let's see. 3 goes into each of them. Does 4 go into each of them? No, it doesn't go into 30. Does 5 go into each of them? No, it doesn't go into either of these. 6 goes into each of them. Does 7 go into each of them? No. 8? No. 9, 10, 11, 12. None of those really work. So the biggest number that goes into each of those is 6. If you're unsure of how to find that, you can always write out the factors. So let's do that now. Factors of 36, well, we have 1 and 36. I'm going to leave some space in between there. 2 and 18. 3 and 12. 4 and 9. And 6 times 6. So 36 has a lot of factors. Here are all the factors of 36. 24 has, you can do 1 times 24. You can do 2 times 12. 3 times 8. You can do 4 times 6. And that's it. So these are all the factors of 24. For 30, you can do 1 times 30. You can do 2 times 15. You can do 3 times 10. Can't do 4. You could do 5 times 6. And those are all the factors. So we look at this list. What's the biggest number, the largest number that goes into each of these lists? It is 6. So for the numbers, we're pulling out the highest number that goes into each of them. So that's 6. And then looking at our variables, we want to pull out the smallest variable. So here we have c to the 1. So looking at our c's, we have c to the 1, c to the 3, c to the 2. The smallest of those is c to the 1. And you can either write c to the 1 or just write c. For the d's, we have 4 here, 2 here, and 3 here. So the smallest of those is 2. Now, what's left on the inside? For the numbers, again, we have 3 terms, by the way. So we need 3 terms inside our parentheses. For the numbers, what number times 6 gives us 36? That number is 6. For the variables, we have c to the 1. We already pulled out 1c, so we don't have to write a c. Here we have 4 d's. We pulled out 2. We have 2 left over. Next up, we have 24. We pulled out a 6. So 6 times, this is positive 4, gives us 24. And then we have 3 c's. We pulled out 1, so we have 2 left over. We have 2 d's. We pull out both of them, so there's nothing left over there. And then last, we have negative 30. What times 6 gives us negative 30? That is negative 5. We have 2 c's. We pulled out 1, so we have 1 left over. We have 3 d's. We pulled out 2, so we have 1 left over. And this is our final answer. And again, our GCF, our greatest common factor, is 6cd squared. Let's try another. So here we have, we want to know what we can pull out of each of these numbers, 35, 15, negative 25. The biggest number we can pull out of each of those is 5. And then the variables, we have e to the 1, e squared, e to the 5th. The smallest of those is e to the 1. Then we have f to the 7th, to the 5th, to the 3rd. The smallest of those is f to the 3rd. So on the inside, what number times 5 gives us 35? That's 7. We have 1e, we pulled 1 out, there's none left over. We have 7 f's, we pulled 3 out, so there's 4 left over. Next up, we have 15. What number times 5 gives us 15? That's a positive 3. And then we have 2 e's. We pulled out 1, so 1 is left over. We have 5 f's. We pulled out 3, so we have 2 left over. And then we have negative 25. So what number times 5 gives us negative 25? That is negative 5. We have 5 e's. We pulled out 1, so we have 4 left. We have 3 f's. We pulled out 3, so we have no more f's. So that is our answer. Let's try one more. So here we have 40, 70, and negative 10. The biggest number that goes into all of those is 10. And then we choose the smallest in our variables. So we have g to the 5th, g to the 4th, g to the 4th. So we can pull out 4 g's. And then for h, we have 2, 4, and this one is 1. So the smallest of those is just 1h. And then we can look at what's on the inside. Again, we have 3 terms, so we should have 3 terms. So what times 10 gives us 40? That is 4. Here we have 5 g's. We pulled out 4, so there's 1 left over. Here we have 2 h's. We pulled out 1, so there is 1 left over. What number times 10 gives us positive 70? That would be positive 7. Here we have 4 g's. We pulled out 4, so we have none left over. 4 h's. We pulled out 1, so we have 3 left. And last but not least, we have what number times 10 gives us negative 10? That would be negative 1. We have 4 g's. We pulled out 4, so we have none left over. 1 h. We pulled out 1, so we have none left over. So here we have minus 1. So this is our solution. Now a quick note, some students see that there are no variables here, so they won't write in this last term. Remember, if you have 3 terms and you're factoring out, you need to have 3 terms inside your parentheses. Okay, this is the biggest error that I see a lot of students make. We're going to get a lot of practice on this. This is Objective 60.